computer. Now I go and record that one, and I go and share the course outline. Now, I'm not going to go through this, word by word. I'll tell you, I'll let you over review for you. Statistics is divided critically into three main components. Call them components for now. One, the first part, which you must first undertake, is called descriptive statistics. Descriptive statistics. Any BCom, any international finance student, any wherever, must have done in business. In fact, all students these days do statistics at undergraduate. So descriptive statistics, to describe anything, is to talk about the attributes of what you're describing. So if you're describing Ochola, you can say Ochola is black, Ochola is short, Ochola is blah, blah, blah. What you can see. What you can see. You can describe data, you can describe a business phenomenon by what you can see. And what you can see in statistics is called visualization. You visualize. Now, there are many ways of visualizing the behavior of, say, a business phenomenon or whichever phenomenon. You can visualize them using tables. You can see a table. Then you can derive trends from a table. You can also visualize them using diagrams. Diagrams. So you have a tabular data representation. That's the first thing you need. How do you convert data into tables, then interpret the tables? Interpret the tables in the context of the problem. That's what you can see. And there's only one table we'll draw, which is the mother of all statistical tables, and that's a frequency distribution table. So you have a whole PowerPoint presentation for frequency distribution table and its use, how you construct them, and how you interpret them. So that's one way of visualizing. The other way of visualizing is through diagrams. You can also see a diagram. In fact, the days of analytics these days, big data analysis, visualization is a key component of analytics. Managers don't want to see big data. No, a manager just wants to see how data has been reduced into a diagram, how it has been reduced into a table. Large data, you take about health data, queuing times or service times or operation times in a theater. How long a surgeon takes in operation on average. They don't want to see the numbers. They just want to see diagrams plotted against probably those surgeons, probably per week, per month, per year. That's what they want to see. So visualization is a key component of decision-making processes, whether it's for business people, whether it's for engineers, whether it's for medical people, even for lawyers. Backlog in the courts, court backlogs. Court backlog, you go into a court in this country, the magistrate courts, and you want to look at the queuing, the case backlogs, and the factors that contribute to magistrate court efficiency. All I need to know is a diagram or a table at the lowest level. That's what I want to see. So visualization is a key component under this course because of its wide use. Now that is under descriptive statistics, the first part, the tabular and visualization. Then all these things are here. You don't have to copy them. They are here. I don't want to do this thing one by one. The next part of descriptive statistics are called now summary statistics. Remember, visualization you can see. Visualization you can see. But summary statistics you cannot see. If you want to visualize me, I'm black, I'm tall. But if you want to describe me by what you cannot see, there are many ways you can describe me. I'm a Seventh-day Christian. So you will look at the distribution of Seventh days. I'm from Homa Bay. I'm from Kenya. Those are things you cannot visualize, but you can appreciate. So summary statistics also describe data, but through what you cannot see. And there are a number. There are actually 4. Summary statistics. So sorry, let me leave summary statistics first. Let me go back to diagrams first, actually. Just a bit, so that I give you comprehensively. Under diagrams, under diagrammatic visualization, under diagrams, you will deal with things like diagrams you can draw in statistics are called pie charts. Simple bar diagram. But those ones for at this level, pie chart, simple bar diagram. People rarely use them because they don't allow you to do certain things. They don't allow you to make comparisons. They don't. If you want to compare the, let's say, mobile money utilization by student at USIU, we know a number of mobile money platforms in this country. Then we divide the student to USIU by gender. I cannot use a pie chart to compare. No, we need a one diagram that can allow you to compare. And now these are the following diagrams you deal with. So of course, the lowest level is pie chart. The other level is the simple bar diagram. But the most important ones are multiple bar diagram, which you should be concentrating on going forward. And we'll show you how to construct a multiple bar diagram. If you don't want to use a multiple bar, you use its surrogate, which is the component bar diagram. You don't have to use both. You use one that appeals to you, that you can interpret easily. So those are good diagrams because they allow you to compare things. I can compare students by gender across all the 47 universities using one diagram. Not many pie charts, not 47 pie charts, or 47 simple bar diagrams, one diagram. But if you want to use other diagrams, there are also others. Stem and leaf. We'll show how to do a stem and leaf diagram. A stem is a stem, the stem of a tree, the leaf of a tree. A stem and leaf diagram allows you also to compare. Or dot plots. Dot plots also allow you to compare. You also compare using dot plots, among others. So those are diagrams. But under graphs, which are also used in visualization, you have graphs like scatter plots. Scatter plot you'll use in PASS 6225. But we'll show you how to draw a scatter plot here and interpret it. So those are the diagrams you can draw. Sorry, I forgot about that. The diagrams you can do, which are in this course outline anyway. Then now I go back to my summary statistics. The first summary statistics are called measures of central tendency. In some textbooks, they're just called averages. They're just called averages. And there are 5 averages. The first one is the arithmetic mean, which we'll deal with here. But for you, again, it's not just calculating the mean for the sake of knowing how to calculate. You are not doing mathematics. You must calculate the mean and interpret the mean, whether you are asked or not, because you're not doing mathematics. So that's something you must go online and you deal with this thing in your area of specialization. Then the next one is the mode. The mode, the most frequent value. The median. We'll use the median here. The mean absolute deviation. We'll deal with it here, among other things. So, sorry, the mode, the median, the geometric mean, the harmonic mean. Those are the means we are going to deal with. The arithmetic mean, the mode, the median, the geometric mean, and the harmonic mean. All those means have their uses. When central bank talks about inflation, average inflation rates, they are not talking about the arithmetic mean. No. When Nairobi Security Exchange talks about the average stock prices, they are not talking about average stock prices based on the arithmetic mean. No. When banks report average profits, they are not talking about the arithmetic mean. They are talking about other means. When Bata Shoe wants to produce, say, shoes at the end of the year for females, Then they want to know the size to produce. You know, then they send some enumerators to Westlands and ask them, the ladies, their size of shoes. They probably collect data from 1,000 females. They go back to Bata. Then Bata wants to, Bata cannot manufacture their 1,000 sizes they have brought. No. Bata can only manufacture one size. And the size they are going to manufacture is not the arithmetic mean, but another mean. So these are the things I'm talking about. That even those measures of central tendency, you need to know when they are used and for what purpose. And of course, I've given you some examples in your PowerPoint presentation. Now, number two are called measures of variability. Measures of variability or dispersion. Variability or dispersion. Whenever you calculate as a measure of central tendency, those averages, you must accompany it with how far away the actual values are from that average. That's important reporting. For complete reporting, you must say how far away on average the actual values are from that mean. And you'll see when you come to the actual top content. Now, this how far away is what is called the measure of dispersion. And here we are only going to deal with three. We are going to deal, the first one is the range, a very good measure, crude, useless, rarely used, but also it's a good measure. It gives you an indication again of how far away. The wider the range, the wider the dispersion, and hence the more distributed the data. You will see that. Then there's the variance. What is variance? Again, we calculate variance. Variance means different things to different people. To finance students, what does variance mean? To accounting students, accounting people, what does variance mean? What does it mean? Engineers, what does variance mean? What does it mean? It means different things to different people, but it serves the same purpose. It serves the same purpose. Then, of course, you have the standard deviation, which is derived from the median, so from the variance. Of course, its use is the same as the use of the variance. Then there we have what is called the coefficient of variation. Coefficient of variation. All these things are here. You'll see them. I'm just giving you an overview, what you're going to cover. That is the best measure for comparing dispersion. You cannot compare dispersion using different variances or different standard deviation. No, you need one value that can allow you to compare dispersion in more than one data set. Then you make a common statement about their differences in dispersion. And then, of course, you have what is called the mean absolute deviation, widely used in forecasting. These guys, who are they? These decorative people. What are they called? These people, the weathermen. The weathermen uses mean absolute deviation. Even now, they're using mean absolute deviation to determine the accuracy of forecast. It is the best indicator for measuring the accuracy of forecast. So if you're a forecaster, and most of you are forecasters, really, then the best measure of determining the accuracy of your forecast will be the mean absolute deviation. We'll show you how to calculate the mean absolute deviation also. So that's the third summary statistics. So when you tell somebody to derive summary statistics, this is what they're talking about. Get all the measures of central tendency, appropriate ones. Get all the measures of dispersions, appropriate ones. And then thirdly, get measures of shape. And the only three measures of shape. One of them is called skewness. Then symmetry. And of course, later on, you'll see kurtosis. So that's the third, we'll calculate all that. That's the third summary statistics. And then lastly, the last summary statistics is called measures of location. Measures of location. In this university before, long time, sometimes back, but it still works in the mother university where it came from. when you're supposed to be admitted, the form you used to be asked to fill your position in a class. So they used to give students a table. I don't think it's there anymore. And that table is asking you to indicate your percentile position. Your percentile position. So you get a student from Kenyatta University who is coming to USIU. He has been sent a form to fill. This fellow, his admission has not been based on a percentile. So the question I want to ask you, so that I check whether you are here, which is a better percentile position? The 3rd percentile or the 97th percentile? Which one is better? Anybody? Which is a better percentile position? Irene? Eh?
Oh, sorry, I was talking while I was still muted.
Which is a better percentile position, the 3rd percentile or the 97th percentile?
I'll say 97th, just a guess.
97. So that means
Yeah.
that so you are admitted in this university.
Yes.
So it was not, therefore it is not in the form. You know, 97 percentile means that only 3 people are behind you, eh?
Okay.
Eh? Umeshika mkia, unanisikia?
Nimeshika.
Shika mkia, sio?
Yeah.
The best percentile is the 3rd percentile.
3rd.
Meaning only 3 people are in front of you, isn't it? It's just that just the 3rd position really out of 100, eh? The 3rd position out of 100, the 4th position. That's what a percentage simply. So you can, so there are a number of measures of location. One of them is the median, incidentally. Median is a locational measure. Then you have the percentiles. Then you have the deciles. This is over 10. So you can convert them into hundreds or into tens. Then of course, but because you just know that this is a position out of that 10. Eh? So if I talk about the first decile, then you're the first student out of 10. Second decile, second student out of 10. So that's really a terminological issue. So those are descriptive statistics. And that's what you're going to deal with. First component of this course. It is here. Here. That is it. Week 1 to 4. Week 1 to 4. And that is assignment 1. That is the assignment 1, which you will hand in assignment 1, you'll get in the blackboard, which you will hand in week 5. So in week 5. In fact, some of the statistics will be in assignment 2. Sorry, in assignment 2. That's what I'm telling you, which you'll hand in later. Then the next one. So that's the first category of statistics. The 3rd category of statistics is called inferential statistics, which you don't deal with in this course. Here you only deal with descriptive. But in this course, you deal with a body of knowledge that allows you, when you go to verse 6 to 5, you now appreciate, you can now link descriptive statistics and inferential statistics. And this body of knowledge is as follows. Introduction to probability. Business processes are governed by probability. There is no business process or any other process, whether even if you're in court, the likelihood of somebody being jailed is governed by probability. There is no phenomenon which is not probabilistic. And hence, we are going to give you fundamental knowledge of probability, that not mathematics, that you require to link descriptive statistics with inferential statistics. And this is what you are going to cover in week 8 and week 9 after the third the mid-semester. Then week 10, now this is it now. So this knowledge here, I'll give you an example so that we are clear. This knowledge here now allows you to build a model. A model is a mathematical representation of reality. So you can have a mathematical model. You can have a model which is diagrammatic, which is the diagrams there. You can have a model which is an icon like these dolls. You know, these dolls kids play with are icons. Eh? they are similar to the real situation, but smaller in scale. But you also have mathematical models. Some of them are probabilistic. One of them is called descriptive probability distribution. Descriptive probability distribution. When I go to a banking hall, and I look at I'm standing there waiting to be served, I see 4 tellers. You never wonder how those tellers, the bank decided to have, say, just those tellers. People don't pause to wonder why. There is a probability distribution that governs teller service time. So analysts, consultants within or without the bank will advise the bank that this, based on the data you have, you only need 4 tellers. You need 4 tellers, not 10 tellers. And even these 4 tellers, should not be there throughout the day. They should be there during time windows. Also, when you are at a traffic junction, remove the police because they're causing confusion. Then a properly working traffic light will sense where the traffic is heavy and allow vehicles to flow based on where the traffic is. And that's analytics. Again, there's a probability distribution that enables to get the likelihood of the traffic being heavy at that junction. NTSA, they say some road sections are black spots. They don't just wake up in the morning and say this is a black spot. No. There is a probability distribution that is used to determine the likelihood of an accident occurring. And one of those probability distribution will cover it here. And that is the Poisson distribution. And we'll show you how to model Poisson distribution to solve problems like infant mortality, to solve problems like congestion in queues at service stations, petrol stations, at traffic lights, at hospital facilities, at maternity wards. They want to get the optimal number of beds. People normally use Poisson distribution. It is here. And that is part why we're covering what I've highlighted. Then the others we'll cover here are the binomial distribution. Again, wide application. Those are under what is called discrete probability distribution here. And you see why they are called discrete. Because reality is never, discrete simply means whole numbers. They only produce whole numbers, not fractions. So you can only use this to model a model system that can produce whole numbers, number of customers in a queue, number of cars at a traffic junction, number of kids dying under 5, blah, blah, blah. But where you do not have numbers, whole numbers, now you can include fractions. Now you have what is called continuous probability distribution. Again, we'll cover here, and there are 5, but we only cover 1. And that is the normal distribution here. And there are 5 of them. And this is what you use in BAS 6225 and other applications. This is now body of knowledge required to link descriptive inferential in BAS 6225. Then after that, then we'll cover these 2, sampling and sampling distribution. And that I don't want to go to jail for now. And then estimation theory, not the mathematical estimation theory, but we'll tell you what we are estimating here. You'll have estimated them up here anyway, under what? Under summary statistics here, under summary statistics. These ones here, you'll have covered some of them here, summary statistics. So we simply come and now apply them down here, and then we go to university examination. University exam. So for university exam, the only thing that I want to show you here is here, 5. That's police, yeah? 5, eh? You're getting me? The assignments are how many here? What's the total here? Are in your class rep? What's the total?
For the assignments, you said 3.
The total, what's the total marks there?
40% it shows.
What's the pass mark at USIU? You should tell us. You are a student here. What was the pass mark at USIU? Huh? Oh, you finished long time ago?
Yeah, long time ago.
When?
2013 is when I graduated.
Jesus Christ, Jesus. Anyway, let me tell you. Here, 45. This one here. So this one here is 30. So pass mark here is 60. What is 60 in USIU? I'll show you, 60. 60. Where is 60 here? Are you seeing 60 here? This one. You see that one? The Fred?
Yeah.
6 is the D minus,
Yes, I can see.
That one you will not move to 6 to 5. You will not go. So your life should be here. Where is B? Here. Are you getting me? There. That's where you should aspire. At least a B. But at worst a B minus. Avoid these things. Avoid these things, these ones. Completely. Avoid them like you'd avoid anything that will hurt you. Therefore, hand in your assignment in time. Attend all classes. You have 45 marks. You just need 35 to get 80. And the 35, you can easily score from here and here. And you're passed. The other day is to pass and move on with your life. You're not going to high school again. Pass and move on with your life. Attend all your classes. Submit your assignments in time. Of course, correct assignments in time. Then come and look for 30 marks, 35 marks. You are home and that. And that is your course. Any question, please? We are done with the introduction. Any question, please?
I have a question.
Yes, please. Yes, Irene.
It's Janet, I have a question.
Yes.
About the assignments. You said there are 3 assignments. Are the 2 individual assignment and 1 group assignment,
Yes.
or the 3
Yes.
are?
Yeah, 2 individual, 1 group, but it can vary. It depends on your behavior. I said something here that the whole idea in this course is not that you fail. This is not high school, This is not high school. If you know that learning will be reinforced through group assignment, I can still convert an individual assignment to a group assignment. You are getting what I'm saying? It depends on the behavior, but for now you'll be posting 2 individual and 1 what? 1 group. But if we know that learning can be reinforced through group, I can convert individual into a group of what? Assignment. Because why? Because when group assignment, you're supposed to do individually, then come and contribute to your group. That's how the group assignment is done. So you will still have met the individual objectives of those assignments. But a good question. For now, 2 individual, 1 group. And the 1 group will be the SPSS assignment, which we'll deal with actually sometimes in week 4. Any other question, please? Okay.
Hi.
Yes, Chris.
I was asking, we don't have cards.
You don't have
Cards.
cards?
Yes.
No, card now. Yeah. Irene, now this is now you're
Yeah.
right? Now you need to link with the school, But I'll tell you what to do. You go to the I think it's registrar's office,
Okay.
You ask them, They will sort you out. But now when you have issues, now you have a group. Irene will go to talk to the school, then she will tell you, But for this one, is go to the registrar's office, It's just that I think they know it's a finance issue normally, That of course, if they have not captured you in the system, then it's a delay, yeah? But just go check with them. When you send them an email, they will sort you out. I know they are efficient. They will sort you out even if you send them an email. They'll tell you.
Okay, I didn't mean those cards.
Yes.
I didn't mean those cards. I
Like
didn't
quizzes.
say cards. I was
Tests?
asking continuous assessment test.
No, hakuna. You know, I gave there. You see what I saw there? I wrote there mid-semester. Eh? The only two modes of assignments, eh? Assignments, mid-semester, and end of what? End of semester.
End of sem.
That's the mode of assessment here. There are no cuts, eh?
Okay.
Yes.
Okay.
So, any other? There's none. Can always sign off. Eh? So next week is I'll put a recurrent link on the Blackboard. So every week you come 7:20, you just enter. Eh? There'll be no waiting.
Okay.
Eh? Just enter. Just go to your class. Like you get it there. Just enter every weekend. So.
Excuse me, sir.
Yes.
The link to the YouTube videos will also be shared on Blackboard.
No, I'll share both ways. I'll come share both ways. That's what I'm talking.
Okay.
Okay, that's also including Excel and SPSS. Are there any tools that you'll be needing?
Excel, no. Excel is just Excel. Actually, just a minute. Just a minute. Just take a pen. Eh? I think just take a pen. This is a quick one. Eh? Just take a pen quickly. Eh? Very quickly, please. I'll tell you what to go and do. And if you fail next week, you ask me. Eh? I'll show you what you're going to do today yourselves. Eh? If you fail next week, just ask me. You will be sorted. Eh? I'm talking this Excel. Eh? This is a quicker one to deal with. Eh? Go to Excel. There's Excel. Yeah? You see that, eh? Now, look at Excel. Look, this is the normal Excel. All of us have Microsoft Excel. And you see data here. You see, the statistics deals with data. You're seeing data here, eh? So don't worry about this, but I'll show you. If you go to your Excel today, and click data. I've clicked data. Click data there. I've activated data. And you look across these shortcuts, here. You will not see this thing. Are you seeing this? Are you seeing what I'm pointing here?
Yeah.
On the far right, eh? You seeing that, eh? If you go to your Excel today and click on data, you will not see this shortcut here. This is what you add. This is the data analysis tool pack. You don't have it because people never install it. There are 4 add-ins that you can only add in when you want to use them. 1 or 2 of them are for IT people. 2 of them are for statisticians actually IT and statisticians, and they use them. So how do you add this in? Now that's what I wanted to tell you. I want just to confirm that when you click your data today, you will not see this thing. This is what you add in. Me, I have added it in, so it is here. So to add it in, you go to File. So click on File. So just right click on File. You're there?
Yes.
Then you go to Options. In some Excels, you'll see an item here called Add In. Don't bother with that one here. Eh? Just click on Options here. Options. Eh? Options. It gives you a dialog box. Are you seeing that one there? Are you seeing what I've shown you there?
Yes.
Those are all Excel options. Everything in Excel. Everything in Excel. You have got general features of Excel. That's not our issue here. We have formulas. You can add formulas. That's not our issue here. Proofing, saving, language. These are all tools in Excel. Our interest is here. Are you seeing this, eh? Are you seeing where I'm pointing, eh?
Yeah, the add-ins.
Then click on add-ins. Just click on add-ins. Don't do anything. Just click on add-ins. You wait, and then it will give you another dialog box. There, just write an add-in dialog box results. Just write that. An add-in dialog box returns. Eh? That's what you get, and you can, all of you can see that. Eh? Clear? Now within dialog box, of course, the default is down here. Manage Excel ad. That's the default. But some IT people sometimes use this thing. So you may find the default here is not Excel. You may find the default here is .com or XLM, among other things. But if you find it's not the same, if not this, just click here. You getting that, eh? Don't, you see, when you are in add-ins, you have got add analysis toolpack highlighted. Just leave it the way it is. If it is here, just come here. If it is here, just come here. Analysis toolpack is here. That's what you want. Then I check down here, manage, clear. Then I click on what here? I click on what here? Okay.
Okay.
When you click on OK, this is what you will see, I can tell you. Or just click on go, whichever you want to do, eh? Then just say either OK or go, eh? It doesn't matter. Then now when you do that, for you, eh? You will get this. I wish I could remove this, eh? So that I can show you what I'm talking about, eh? Let me remove this quickly, eh? I want to show you this quickly, what I'm talking about here. Come here, I come there, I come to add in, analysis toolpack, I go to go. When I go to go, you see here analysis toolpack, eh? This one, eh? See here, the default one, they are not ticked, nothing is ticked, eh? So if nothing is ticked, I will not get this one here, eh? So you must take this. When you click on go and take this, eh? Take analysis toolpack, because somebody else will take this. Somebody else will take all of them. Like me, I would take this, I would take this, I would take this, I would not take this, I would not take that. So that's what for. Yours is this and that. But for now, just remove this, remain with this one here, analysis toolpack. Then do OK. Then now you will be safe here. You will be safe here with this. So now after that, you go to data. After you're in data, come and click here, and I'll show you what you have done. Are you seeing this? What is here? Are you seeing what is here? What I've shown on the screen?
Yes.
Descriptive statistics. You have just talked about it, isn't it? Eh? We just talked about it in the course outline, eh? But this one only gives you summary statistics. It does not give you diagrams. Then other things here, nothing. You see, nothing. So that's something. This is what I'm trying to say. That Excel, though it is usable, it is highly limited. But people use it. People use it for inferential statistics. They are all here. Here. Predictive statistics is here, which will be later in about 62.5. All other, but for descriptive statistics, Excel is weak, very weak. It only allows you to calculate a few things, you know, very few, you know, the mean, the median, all this done, not higher level. That's why people don't use it much. But it's good to know that you can use it when you reach bar 6225. Or when you are just doing basic analysis, you know, which is probably not academic, basic analysis. So that is what you go to do. If you fail to activate that's this one here, then just come, we'll show you next. In your own Excel. But again, next week, all of you should have attempted to install SPSS, install SPSS early enough, so that you know you avoid the crowd when they start installing them. So Sasa, you can stop there now.
Okay, thank you.